Hello everyone. As the second PU students are preparing for the final exam, which will be conducted in the month of April 2022, the 5-mark questions are going to play a vital role. So here in this video, I'll be discussing about the probable question that could appear in the final exam. This time there will be about 12 5-mark questions, out of which the students will have to attempt 6 questions. There will be 2 questions from relations and functions, and both will be based on invertible functions. We have 1 question from matrices, that is to prove the properties. There will be 1 question from determinants, that is to use the matrix method to solve the system of equation. We will have 1 question from differentiation, that is on the second order derivative. 1 question from application of derivatives, that is on the rate measure itself. We have 1 question from integration, and here it will be a derivation. You will have about 6 to 9 questions, out of which 1 question will come. And there is 1 question from application of integrals. This question will be to find the region bounded by the curve, mostly a circle or an ellipse. Then there is 1 question from differential equations, and this is going to be a question where you'll have to solve the or to find the general solution for a linear differential equation. We have 1 question from 3D, which will be a derivation. Out of 4 derivation, in 1 will be asked. Then there are actually 2 questions from probability. So total of 12 questions. You could select about 8 questions which you find easy and which you are very comfortable with, so that in the exam you could answer 6 questions perfectly without any mistakes. So what could be those 8 questions? I would say these 2 questions are actually very easy, though a lot of students leave the probability chapter. They're actually easy. We have 2 questions from relations. In fact, they're easy, but a lot of students have allergic towards the relations and functions chapter. And these 2 questions from matrices and determinants, students find it easy, but they are actually lengthy and they are time consuming, and students can make mistakes also. 1 mistake, small mistake, could take the whole problem wrong. We have 1 question from differentiation. It is also very easy question. I would say that 59 question is also very easy, since you have very less options there. The questions could be either the region bounded by the circle or an ellipse. So these are the few questions I want to mark, which are very easy questions. In fact, the 61st question is also, since it is a derivation. So all you need to study is 4 derivations, in which 1 will be asked. Let's now go through each one of those questions one by one, and let me solve 1 question each from these. The first question is the 52nd question. Here, either you will be asked to verify or to prove the function is 1, 1 and on 2. Let me try the first question. So what do we mean by 1, 1 function? A function is said to be 1, 1 if distinct elements in the domain have distinct images in the codomain. So to prove this, what I do is, suppose f of x1 is equal to f of x2. Assume that these 2 images are equal for x1 and x2 belonging to the domain. The domain is R minus 3. Now, what is f of x1? Looking at the definition of f of x, we have x1 minus 2 divided by x1 minus 3 is equal to x2 minus 2 divided by x2 minus 3. Cross multiplying this, we get x1 minus 2 into x2 minus 3 is equal to x2 minus 2 into x1 minus 3. Simplifying it further, we get x1 into x2 minus 2 times x2 minus 3 times x1 plus 6 is equal to x1 into x2 minus 3 times x2 minus 2 times x1 plus 6. Let us cancel the terms which could be cancelled here. And what remains here is minus 2 times x2 or else we could write it as let us see minus 3 times x1, and let me bring this term this side, that is plus 2 times x1 is equal to x2. Let me shift it to the other side. So we have already one term here, that is minus 3x2 plus this term, I'm shifting it to the other side. It becomes plus 2x2. So this implies minus x1 is equal to minus x2, and that implies x1 is equal to x2. Whenever the two images are equal, the corresponding pre-images are also equal. That's what we have shown. So that means the given function is f is 1, 1. Let's now move on to the other part, that is how to prove that the function is onto. The meaning of onto is every element in the codomain must have a pre-image. So let us say the first set here is the domain, the other set is the codomain. Every element in the codomain, that is, let us say an element y, must have a pre-image x. All we are going to do is this itself. For every y in the codomain, we are going to find out one x in the domain. To do this, what we do is for let y belonging to the codomain here is r minus 1, be an arbitrary element such that f of x is equal to y. Now this implies, what is f of x? We have x minus 2 divided by x minus 3 is equal to y. Cross multiplying this, we get x minus 2 is equal to x into y minus 3 into y. Let us bring all the terms of x to one side, that is x minus xy is equal to all the other terms. I'm shifting it to the other side. We have 2 minus 3y. This implies x is common here, which is equal to 2 minus 3y divided by 1 minus y, which belongs to the domain, that is r minus 3. So we have proved that for every y which we have taken from the codomain, there exists one x which belongs to the domain. So let us write the conclusion. Therefore, for every y belonging to the codomain, that is r minus 1, there exists x belonging to the domain such that f of x is equal to y. Therefore, f is onto. This is how we actually prove the function is onto. In fact, you could try the other questions also, where you will have to prove that the function is 1, 1 and onto. Suppose the function is said to be, prove that it is invertible. What should you do? All you need to do is to prove that the function is 1, 1 and onto. And whenever a function is bijective, that means 1, 1 and onto, it becomes invertible. And some questions, they might ask you to find out the inverse also. In fact, the inverse is this itself. This is the inverse. How do we do it? Let me just show you here, though in the question they have not asked how to find out the inverse. So you write y is equal to f of x. So this implies, shift f to the other side, you have f inverse of y is equal to x. This implies f inverse of y, that is the inverse of the function, is nothing but, what is x here? X is nothing but 2 minus 3y divided by y, 1 minus y, which is the inverse of the given function. So this is how, from the onto part itself, you can get the inverse of the function. Let me move on to the next question. This is again a question from relations and functions, where the question will be to verify or to prove that the function is invertible. So here in this, the first two questions you see, we have the quadratic expression. So here you will have to rearrange these terms slightly and then proceed. I'm not going to do the whole problem since it is same as the previous question, but only I'll tell you how should you write the given function. Let us say the 4x square plus 12x plus 5 if it is given. So first what you should be writing is, try to express this given expression in the form of a square plus 2ab plus b square. Okay, if there is something extra that you could write at the end here. So first what I'll do is I'll write this as 2x whole square, which is nothing but a square, plus 2 times a is nothing but 2x for us. But what we have here is 12x. What we have written here is just 4x. Into 3, if I write, it becomes actually 12x. Plus b square is nothing but 3 square, that is 9. Plus we have actually 15 here, but I have written only 9. To balance it, I'll add 6 here. Now the first 3 terms are in the form of a square plus 2ab plus b square. So they can be written as 2x plus 3 whole square plus 6. Once you have expressed the function in this form, you could proceed in the same way what I did in the previous question. Yes, let's move on to the 54th question. This is for matrices. I'm not going to solve this problem because all the students find them easy. So you will have to prove some properties like a plus b whole dash is equal to a dash plus b dash. That this stands for transpose. Okay. And you could have a question like where it is the distributive law you'll have to prove. Here also the distributive law. So sometimes it may be the associative law we'll have to prove. So basically the question will be on some properties of matrices which you'll have to prove them. Next question, the 55th question is from determinants, and this is one of the most predictable question where you will have to solve the system of equation by the matrix method. Let me try the first question here. Most of the students would know this, but for those students who are not very familiar with, so what first we should do is we'll have to write what is the matrix A. This is actually called as the coefficient matrix, where I'm going to write only the coefficients. Let us say 2, 3, 3. Then the next row will be 1 minus 2, 1, 1 minus 2, 1. And the third row is going to be 3 minus 1 minus 2, 3 minus 1 minus 2. This is the coefficient matrix. The next one is the unknown matrix, that is x, y, and z, the column matrix. And finally, the constant matrix B is equal to, it is equal to 5 minus 4, 3. Now, this system of equation has a solution if the determinant of A is not equal to 0. Therefore, first let us find out what is the determinant of A. The determinant of A is nothing but 2 into 4 plus 1 minus 3 into minus 2 minus 3 plus 3 into minus 1 plus 6, which will be equal to 2 into 5 is 10, and this is plus 3 into 5 is 15, plus 3 into 5 is again 15. So it is 30 plus 10 is 40, which is not equal to 0. The determinant of A is not equal to 0 means the solution exists. So we can go ahead now. Next part is, in fact, x is equal to A inverse into B. That is because the given system of equation can be written as the matrix equation as Ax equal to B, so which can be further rewritten as x is equal to A inverse into B. So where A, we will be interested in finding x, which is the unknown matrix. Now, before we proceed, we will have to know what is the A inverse. But A inverse is nothing but 1 by determinant of A into adjoint of A into the matrix B. So let me now first find out what is the adjoint of A. So adjoint of A is nothing but the transpose of the cofactor matrix. So adjoint of A is equal to, let me first find out the minors of each of the elements. Minus of each of the elements. So the minor of the first element here, A, is how to find it? It is actually, you have to ignore the row and the column in which the first element is lying and take the sub matrix which is remaining there, whose determinant is nothing but here it is 4 plus 1, that is 5. So this is the minor of it. Next, to find out the minor of the next element, that is 3, would be ignore the first row and the second column. The sub matrix determinant would be 2 minus 2 minus 3 is minus 5. Next, in the same way, we'll have to do the minor of the third element is, again, it is minus 1 plus 6. That becomes a plus 5. The minor of the next element, 1, would be minus 6 and plus 3. Minus 6 plus 3 would be minus 3. Next, the minor of minus 2 is minus 4 minus 9. Minus 4 minus 9 would be minus 13. The minor of 1 is minus 2 minus 9. Minus 2 minus 9 is minus 11. Next, the minor of 3 is 3 plus 6. 3 plus 6 is 9. Next, the minor of minus 1 is 2 minus 3. 2 minus 3 is minus 1. And finally, the minor of minus 2 is minus 4 minus 3. That is minus 7. Minus 4 minus 3 is minus 7. So the adjoint is, what I have written here is, by the way, students, they are all the minors. But I said the adjoint of A is the transpose of the cofactor matrix. So how to make them as cofactors? We'll have to just change the signs now. Alternatively, plus minus I'll have to write. So for the first one, plus, so which I don't have to do. Second one, I'll have to multiply it by minus. So already one minus sign is there, it becomes plus. Then third one is plus, fourth one is minus. So minus of minus becomes plus. Then it is plus, then again minus, it becomes plus. Then plus, minus, plus. So only when you multiply by a negative sign, the sign will change. If you multiply by positive sign, you could retain it as it is. And then this is equal to 5, 5, 5. I'm taking the transpose. 3 minus 13, 11. 9, 1 minus 7. Yes. Now we come to the equation x equal to A inverse into B, which is nothing but 1 by determinant of A into adjoint of A is given here. That is 5, 3, 9, 5 minus 13, 1, 5, 11 minus 7 into the constant matrix B is 5 minus 4, 3. Let us now multiply them. So don't go to multiply this 1 by 14 initially. Let it be at the end, we can do it. This is equal to 1 by 40 into 5 into 5 is 25 minus 12 plus 27. Okay, the next row is, I'm multiplying the next row with the column 5 minus 4 and 3. So 5 into 5 is 25. Minus 13 into minus 4, that becomes plus 52. Then we have 1 into 3 is 3 itself. The last row and the column, 5 into 5 is 25. 11 into minus 4 is minus 44. Minus 7 into 3 is a minus 21. So that is equal to 1 by 40 into 25 minus 12 plus 27. This becomes 52 minus 12, that is 40. Next element is 25 plus 52 plus 3. This becomes 55 plus 25. 60, 70, 80 it will be. Yes. Then we have minus 44 minus 21. It is minus 65 plus 25 becomes minus 40. So this will be equal to, if I'm now we shall multiply 1 divided by 40, it becomes 1, 2 minus 1. So this will be the final answer. So usually if you give some strange numbers here, then you should get a doubt that the answer must be wrong. Usually you get some simple numbers like 1, 2, 3, 1, 2 minus 1, such answers. And you could verify it also. You could just substitute these values in these equations and check whether the answer is, if those values satisfy these equations, that means what you got here is the right answer. Let's now proceed to the next question. The 56th question is from differentiation and one of the easiest questions. A lot of students attempt these questions and they try to solve it as where y will be given to us and we'll have to prove this one equation. So this is actually a differential equation. So we'll have to prove this. So a lot of students, what they do is first find out y dash, then y double dash, then they substitute here. Y double dash is substituted here, y dash will be substituted here. Then they simplify and they show that it is equal to 0. So that method is correct, but sometimes it is useful in this case, for example, where you have to find out y dash, then y double dash, and then substitute here in the place of a y double dash and y dash, you get the answer. It can be done in this particular question. But in the other questions also it can be done, but I would suggest you to go for another method, which I'll show you here for the first question. What is given to us is y is equal to 3 into cos of log x plus 4 times sine of log x. Let me differentiate it with respect to x. I get 3 into minus sine of log x into 1 by x plus 4 times cos of log x into 1 by x. The moment you see the denominator like this, shift that x, that 1 by x is common here, and then shift x to the other side, we get x into y dash is equal to minus 3 times the sine of log x plus 4 times cos of log x. Again, differentiating with respect to x. With respect to x, we get here I'll have to use the product rule. First function x into the derivative of the second function plus second function into derivative of the first function is 1 itself, which is equal to minus 3 times derivative of sine is cos of log x into 1 by x. Next, minus 4 times, that minus is because the derivative of cos is minus sine of log x, sine of log x into 1 by x, which I'll write it here. Okay. So now, again you have in the denominator x here. So that x I'll shift it to the other side. We get x square into y double dash plus x into y dash is equal to, minus is common in both the terms. So let me take it out. 3 times cos of log x and 1 by x we have shifted to the other side plus 4 times sine of log x, which is nothing but the given expression y itself. So I'll write this as x square into y double dash plus x into y dash is equal to minus y. Shifting minus y to the other side, we have x square into y double dash plus x into y dash plus y is equal to 0. This way of solving it becomes very easy, students. We have proved the required expression here. In fact, you can use the same method for second, third, fourth, or fifth problem. But for the sixth question, I would suggest you to just find out y dash and y double dash, then substitute and simplify it. Okay. So usually, how do you go about here? Once you have found out y dash, the denominator is what you find, you shift it to the other side. So again, you differentiate it. Again, you will have some denominators here. Shift them to the other side. With that, the problem will be over. Okay. Moving on to the 57th question from application of derivatives. Let me try the first question here. They are actually simple questions, but students might find it difficult. So here we have a rectangle. So the length is equal to x, let me call it as, and the width is y. Here it is said x is decreasing. That means the rate of change in x with respect to time is decreasing, that is -5. Since it is decreasing, I'll write it as -5 centimeters per minute. And the width y is increasing at the rate of 4 centimeters per minute. Since it is increasing, I'll write dy by dt is equal to 4. Since it's increasing, it is positive, I have written. Now, when x is equal to 8 and y is equal to 6, find the rate of change of perimeter and the area of the rectangle. So there are two questions. First thing is I need to find out the rate of change. The rate of change means the derivative of perimeter. So what is perimeter? P is nothing but 2x plus 2y, isn't it? Now, the rate of change in the perimeter is nothing but dp by dt, that is 2 times dx by dt plus 2 times dy by dt. I'm differentiating with respect to time. This is equal to 2 into what is dx by dt? Dx by dt is nothing but minus 5 plus 2 times dy by dt is nothing but 4, which will be equal to minus 10 plus 8, that is equal to minus 2 centimeters per minute. Okay. Next question is the rate of change in the area. First of all, what is area? Area is nothing but x into y. Therefore, the rate of change in the area is nothing but dA by dt is equal to first function into derivative of the second function plus second function into derivative of the first function. This is equal to x is nothing but 8, they have given us here. X is 8 into dy by dt is 4 plus y is equal to 6 into dx by dt is minus 5. This is equal to 32 minus 30, which is equal to 2. Since it is the rate of change in the area, square centimeter per minute. This is how we should be answering it. So in the same way, you could try the other questions. For more questions, please click on the link in the description box. Here, we have 6 questions. Sometimes you could have 9 questions also. I have given 6. These are the rational functions and the next 3 are irrational functions. You could have questions like you have root of a square minus x square with respect to x. And most probably, I feel they may not ask those questions. So if you study these questions would be enough. Suppose something else comes also, you have an options are there, so you could manage it. So if you have studied one of these questions, so most probably you will get 5 marks. But here the problem is that you have a question also. Some students might find it difficult. Along with the derivation, you need to know these questions are not fixed. They could change. They might give any question here. Okay, let me try one question here. The first one is the integral of 1 divided by x square plus a square with respect to x. Here I like to make a small substitution. The substitution is I'll take x is equal to a sec theta. In fact, I think it should be a tan theta. Sorry. Now students will be wondering or they will be finding it difficult to make that substitution. Why should it be tan theta? Why not something else? So usually, maybe the first question here you see, we have x square plus instead of a square, you take it as 1. Now in the place of x, which trigonometric function, if you substitute, you'll get one formula there. Let us say, if you substitute tan here, you will have tan square plus 1 is nothing but you have secant square x, right? So in this place, you better substitute x equal to tan theta. Suppose you have, let us say, x square minus 1. In such case, x should be, or it is better that you write x is equal to sec theta. If you have 1 minus x square, you could write x is equal to sine theta or cos theta. In one of them you could write, so that you get some formula there. You have 1 minus sine square theta is nothing but cos square theta. You have some formulas in trigonometry you have studied in first year. So here in this case, I have written a tan theta because of this. It is not just 1, it is a square. Therefore, I'm writing a tan theta. This implies theta is equal to tan inverse of x by a. Let it be this now. Now, first thing what I'll do is I'll differentiate this part. That is dx is equal to a is a constant into secant square theta into d theta, since I've differentiated with respect to theta. Now I'm going to substitute in the given function. We have 1 divided by x is nothing but a tan theta, that becomes a square tan square theta plus a square into dx is nothing but a into secant square theta into d theta, that is equal to, in the denominator a square is common. If you take it out, it gets cancelled with the a in the numerator. So still 1a will remain in the denominator into integral of secant square theta divided by tan square theta plus 1 becomes again secant square theta into d theta. That is equal to 1 by a integral of 1 with respect to theta. That is equal to 1 by a. Integral of 1 is theta plus c. That is equal to 1 by a. Theta is nothing but, I have written it here, it is nothing but a tan inverse of x by a. Tan inverse of x by a plus c. So this is the derivation of the first problem. This question could change. It need not be the same, but you should be ready for any question if you are attempting this question, the 58th one. In the same way, please practice the other questions also. You just can't read them and understand. You will have to write it and understand it. Moving on to the 59th question. I said that this question is easy because most probably they are going to give only two curves, either an equation of a circle or equation of an ellipse. Therefore, I'm saying since only two possibilities they could give, that's why I said that this question is easy. Let me try the first question, or maybe the second question. Let me try only the first part of it. I'll do. So we have an ellipse here. Ellipse looks something like this. Now, let me call this as A. This would be B here. So these are those two values. That means if this length is A, here this point should be on the x-axis. It is A. Instead of writing here, let me write it here itself. Okay. Yes, this point is 0. In order to find out the region bounded by this curve, what I'll do is I'll just find out the region in the first quadrant and then multiply it by 4. I'll get the required answer. Since I'm going to integrate it along the x-axis, the required function must be y is equal to something. What is it here? We have y is equal to, maybe you could write it here in the side. Y square by b square is equal to 1 minus x square by a square. Then further you can write y square is equal to b square into 1 minus x square by a square. Further you can say that y is equal to plus or minus b into root of 1 minus x square into a square. This could also be written as plus or minus b by a into root of a square minus x square. This is how we could write it. Okay. Now, there are two possible plus or minus. I'll take only the first possibility, that is b by a root of a square minus x square. If you put minus, that becomes the lower curve here. Okay. So since I'm interested in the upper curve here in the first quadrant, I've taken only plus there. Now we are ready with the function as well as the limits. So therefore the area is equal to 4 times the integral of b by a root of a square minus x square with respect to x from 0 to a. That will be equal to 4 times, by the way, I hope you all know, since there are 4 regions here. So the to include all of those 4, I have written 4. So we have 4b by a into the integral of root of a square minus x square is, it is x by 2 root of a square minus x square plus a square by 2 sine inverse of x by a. from 0 to a. This is equal to 4b by a into, I'm going to substitute the upper limit. If I substitute the upper limit here, a square minus a square, whole thing becomes 0. Next, we have a square by 2 sine inverse of, if I substitute in the place of x a, I get 1 there, minus, substitute the lower limit. If you substitute the lower limit in the place of x as 0, the whole thing is going to be 0. Even here, if you substitute x equals 0, this is going to be 0. So therefore, I'm not going to substitute it here. So what we have is now 4b by a into a square by 2 into pi by 2. So this is nothing but 4 gets cancelled here. 1 of a gets cancelled. What remains is pi ab square units. So for verification students, usually the area of an ellipse, you should be knowing it. What is it? It is pi ab. So if you have got this answer, that means 100% you are right. Now, if you have to evaluate this area of this ellipse, you don't have to do the whole integration again. You have the already formula. You just apply that formula and get the answer. You have area is equal to pi into a is equal to what? It is nothing but 4 into b is equal to 3. So the answer must be 12 pi square units. Okay, so 12 pi square units should be the final answer. Let's move on to the 60th question. This question will be from differential equations. Here there are two possibilities. Both are linear differential equations only, which you will have to solve. If the given linear differential equation is in this form, then this is going to be the general solution. Most probably, I feel the question will be of the first type only, but there are possibilities they could give a question, rarely I feel, of the second type. So here is I've given the first question, which is of the first type. Let me try to solve it. I don't have much space here. Still, let me try. So the given equation, first make sure that it is in the required standard form. So it doesn't look like it is. Therefore, I'm going to divide throughout by x. I get dy by dx plus 2 by x into y is equal to x, where p is equal to, p is equal to 2 by x and q is equal to x. So here it is said where p and q must be functions of x alone. So are they functions of x alone here? Yes. Once we have found out what is p and q, we'll have to find out what is the integrating factor. The integrating factor is this, e to the power integral of p dx. Okay, so e to the power integral of p is nothing but 2 by x with respect to x is going to be e to the power 2 into integral of 1 by x is log x, that can be written as e to the power log x square. E and log are inverse of each other, they get cancelled, you have x square. So having found out what is the integrating factor, what is q and what is p, now we move on to finding the general solution. The general solution is given by, general solution is y into integrating factor, that is x square, is equal to integral of q into integrating factor. Q is nothing but x into integrating factor is x squared. Total it becomes x cube with respect to x. This is equal to x to the power 4 divided by 4 plus c. Therefore, y is equal to x square by 4 plus c divided by x square. This should be the final answer. So here the second question, third, and the fourth question, I think they are all of the second type. So sometimes you can't make out looking at it, but you should be check is it easy to express it in this form or in this form. Whichever that is easy to express, you should be doing in that particular form, either the first type or the second type. Let's move on to the next question, the 61st question. This is from 3D, where you have 4 derivations. If you study them correctly, definitely one is going to come. Let me try one of these questions, the third one. So the third question is to find out the derive the equation of a line which passes through a given point a of x1, y1, z1 and which is parallel to a vector b. So the required equation is this, which passes through the point a and is parallel to the vector b. So what we shall do is let p of x comma y comma z be any point on the required line. Let the vector a be the position vector of the point a. Let vector r be the position vector of the point p. I want you to write all these statements. It is better that you write in your own words. You don't have to learn them by heart. So whatever the construction part you have done. So in your own words, you go on writing, as I said just now. So now next what you should be doing is, here from the diagram, it is very clear that the vector AP is parallel to the vector B, isn't it? So this implies vector AP should be equal to some scalar times the vector B. That implies, what is vector AP? It is nothing but OP minus vector OA is equal to lambda times vector B. OP is nothing but vector R minus vector A is equal to lambda times vector B. And that implies vector R is equal to vector A plus lambda times vector B. This is the vector form actually. Vector form. Okay. Next, to get the Cartesian form, so every question you will have to get both the forms, the vector form as well as the Cartesian form. So for the Cartesian form is just simplifying the vector form. You know what is vector R? It is a position vector of the point P. So the vector must be x I cap plus y j cap plus z k cap. And vector A should be equal to, it is a position vector of the point A. So x1 I cap plus y1 j cap plus z1 k cap. And the vector B is equal to, maybe I will write it as b1 I cap plus b2 j cap plus b3 k cap. Okay, just name it this way. Now we substitute in the vector form here. We have vector R is equal to vector A plus lambda times vector B. Substituting it, we get x I cap plus y j cap plus z k cap is equal to x1 I cap plus y1 j cap plus z1 k cap plus lambda times b1 I cap plus b2 j cap plus b3 k cap. This implies the next what I'm going to do is I'm going to equate all the coefficients of I cap. Okay. So we have x is equal to x1 plus lambda times b1. Y is equal to y1 plus lambda times b2 and z is equal to z1 plus lambda times b3. This implies lambda is equal to x minus x1 divided by b1. Here lambda is equal to y minus y1 divided by b2 and lambda is equal to here z minus z1 divided by b3. So since all these three quantities are equal to lambda, you equate them and write it as, maybe I'll write it here, x minus x1 divided by b1 equal to y minus y1 divided by b2 is equal to z minus z1 divided by b3, which is the required Cartesian form. So for other derivations, please check your notes book for whatever the teachers have taught you or the textbook and learn them. And if you're planning to attempt the 61st question, you better learn all these 4 derivations. We can't say which could be asked. Any one of them will definitely be asked. Let me move on to the 62nd question from probability. I said this is the easy question. A lot of students may be planning to leave probability, but it's an easy question. So since I don't have much space, I would like to attempt the second question here. So all you need to do here is, first you need to find out the value of n, which is nothing but the number of trials. Next, you need to know the value of p, which is the probability of success. Next, you should know the value of q, which is the probability of failure. And this is the final formula you have in order to find out the probability of number of success, okay, depending on whatever the question that is asked. So I'm trying the second question here. A fair coin has been tossed 10 times, which is nothing but the number of trials. So we have n is equal to 10 for the second question. Then we have find the probability of exactly 6 heads. So since they are talking about getting heads, let me take getting head is a success, not getting head is a failure. So you tell me what should be the probability of getting success. Success is getting head, right? So it should be 1 by 2, right? And the probability of failure, Q is the probability of failure. That means getting tail, that is also 1 by 2 itself. Now the first question here is, what is the probability of getting exactly 6 heads or probability of getting 6 success? So probability of getting x equal to 6 success is, I'm using this formula, students, 10c6 into p to the power 6 into q to the power 10 minus 6, that is 4. This is equal to 10c6 is nothing but 10 into, or I could write it as the 10c4, it is also equal to, then we have 1 by 2 to the power 6 into 1 by 2 to the power 4. Further simplifying it, we have 10c4 is nothing but 10 into 9 into 8 into 7 whole divided by 4 into 3 into 2. So here 8 gets cancelled, 3 3s are, so we have 21 into 10, that is 210 into 1 by 2 to the power 10 we have. So the final answer must be here 210 into 1 by 2 to the power 10, that is nothing but 1024. So this is the probability of getting exactly 6 heads. Now next question here, at least 6 heads. So let me try the next question. To get the probability of getting at least 6 heads. So what is it? What is the meaning of getting at least? That means minimum 6 heads. You should not be less than 6. So the success must be greater than or equal to 6. Minimum, at least means greater than or equal to 6. This is equal to probability of getting x equal to 6 plus probability of getting x equal to 7 plus probability of getting x equal to 8 plus probability of getting x equal to 9 plus probability of getting x equal to 10. So when I say at least 6 heads, it could be more than 6 also. So this is equal to 10c6 into 1 by 2 to the power 10 we have seen. It is, isn't it? Plus this is 10c7 into 1 by 2 to the power, again 10 it will be, since the p and q are equal here, since p and q which we already found out that time equal, I'm combining and writing it here. Then we have 10c8 into 1 by 2 to the power 10 plus 10c9 into 1 by 2 to the power 10 plus 10c10 into 1 by 2 to the power 10. This is equal to 1 by 2 to the power 10 is common, I'm taking it out. So what remains here? What remains is 10c6 plus 10c7 plus 10c8 plus 10c9 plus 10c10, which is equal to 1 by 2 to the power 10 into 10c6 we have already found out, students, that is 210 plus 10c7 you can evaluate it later, it is actually 120 plus 10c8 is equal to 10c8 is nothing but 10c2. 10c2 is nothing but 45. Yes, it is 45 plus 10c9 is equal to 10 itself plus 10c10 is equal to 1. So total it will be, let me write it here, total it will be 210, 200, 300, 345, 355, 365, 366 divided by 1024. Let me recheck it again. 200, 300, 330, 370, 380, 386. I think it's 386. Okay, so even if I made mistake, please correct it, students. Later on by yourself, you have to be very careful while adding. Okay, so this is how the questions could be solved. Let me move on to the last question. That is from probability, but based on independent events. One of the easiest questions. All you need to know is these two formulae. So probability of A intersection B, whenever A and B are independent, is probability of A into probability of B. The other formula is probability of A union B is equal to 1 minus probability of A dash into probability of B dash, provided the events are independent. Let me try one question here. Maybe the first question itself I want to try. Probability of solving the specific problem independently by A and B are 1 by 2 and 1 by 3. Respectively, if both try to solve the problem independently, find the probability that the problem is solved. What is the meaning of problem is solved? Before that, let me write a few things here. Probability of A is equal to 1 by 2 and probability of B is equal to 1 by 3. This implies probability of A dash is what? A dash is 1 minus probability of A, which will be equal to again 1 by 2 itself, isn't it? Next, what is probability of B dash? B dash is nothing but 1 minus probability of B, which will be equal to 1 minus 1 by 3, that is nothing but 2 by 3. So having found out these values, let me try to solve the first question. The problem is solved. That means when I say problem is solved, it is any one of them can solve. That is probability of A union B. I don't have to put intersection here. Intersection means both have to solve it, right? No, here in this case, any one of them is solved is enough, because just the problem has to get solved. Even if one of them has solved, the problem is solved. So this is nothing but using the second formula, 1 minus probability of A dash into probability of B dash. This will give me 1 minus 1 by 2 into 3 by 2. That's nothing but 1 minus 3 by 4. Sorry, 2 by 3 it is. That means it must be 1 by 3. And the final answer is 2 by 3. Yes. And the other question is, the second question is, exactly one of them solves the problem. If A solves the problem, then B shouldn't be solving it. If B solves the problem, A shouldn't be solving. So that means probability of A intersection B dash plus probability of A dash intersection B. That means the first one says A has solved the problem and B has not solved the problem. The other case is A has not solved the problem, but B has solved the problem. Now, since A and B are independent events here, whenever A and B are independent, so are A dash and B dash, or A dash and B, and A and B dash. All of these events are independent only. Okay. So here A and B dash also must be independent. Therefore, I can write this as probability of A into probability of B dash using the first formula, plus probability of A dash into probability of B. This will be equal to 1 by 2 into 2 by 3 plus 1 by 2 into 1 by 3. This is equal to 2 by 6 plus 1 by 6, which is equal to 3 by 6, that's equal to 1 by 2. So isn't it an easy question? Only based on these two formulas, we can manage to answer these questions. So anyway, students, this is the last question for 5-mark questions. Please practice as many questions as possible. Select about 8 questions so that you could answer 6 questions correctly in the exam. Wish you all the best. That's all for now. Let's meet in the next video. That's on the 10-mark questions. Until then, take care. Wish you all the best.